So now further we are moving and we talk about the using oil for short sleeve temperature control. And you can say we can use this to preheat the short sleeve, which is very good idea to make the smoother and increasing the plunger and short sleeve and both. So a common misconception is that the amount of thermal expansion of a short sleeve is simply a factor of its diameter and its maximum temperature. If this were the case, the temperature control would simply depends on the cooling. This is totally incorrect. I would say this is a totally incorrect. The amount of thermal expansion on the or contraction depend on the ID of the sleeve and the amount of temperature change up or down, not on the maximum temperature. This temperature differentially used known as a delta T will cause exactly the same amount of expansion at the any point of the temperature scale. The maximum temperature change in a short sleeve occurs at the bottom under the pore hole. If the short sleeve has been preheated by the circulating hot oil at 250 degrees centigrade, for example, delta will be reduced and consequently so will amount of expansion reduce. In addition, as the pore continues, all temperature greater than 250 degrees centigrade will be reduced as the oil then act as a coolant. A major advantage to preheat the short sleeve is that the startup is scrap. Yes, you must focus on that. The major advantage to preheat the short sleeve is that the startup scrap is eliminated. We can eliminate the startup rejection. There are so many components we have used to reject at the startup casting, and we used to this system, this process, yes, we had to make some of the component rejected at the start of that time. This is a totally wrong practice. We have to remove this by adopting this concept. Okay, so when oil is used for thermal control, short wave temperature variation both top to bottom and back to front can be very closely controlled and the expansion minimized. The zero point 0.1 mm maximum can be more easily to be maintained. If the temperature of both short sleeve and the plunger tip are both not closely controlled, neither can approach maximum efficiency. This is a, you can say, it's a punchline. If you are not able to maintain your short sleeve and plunger temperature, you are not able to control the temperature of short sleeve and the plunger tip, then you are not able to get the maximum efficiency of short end component, or you can say your die casting system.